Hello friends, welcome to another video. In this video, we are going to explore how we can use generate and intersect functions together, or a use case of these functions. To explain where I use these functions together, let's look at Power BI and look at a very simple problem on surface, but otherwise it's a bit of a complex problem to solve. Let's get to Power BI. Again, this was posted on a Power BI community forum. Again, most of my videos are based on questions posted on Power BI community forum because people have some real-time problems they're trying to solve. And again, my channel is all about showcasing the functionality on how we can solve real-time problems. And having said that, make sure to subscribe my channel and do hit that bell icon so that you get notification when new videos come out. Anyhow, let's look at what we're trying to solve here. So the question was posted like this is about the recipes. That there is a product, then it has a components, basically a bill of material in manufacturing industry. You have a product, and then you have a subcomponents of that, and then how much quantity a product you use. And for example, here is a product 448305. It's made up of these four components with this much quantity. And so that's pretty straightforward. And the user gave a simple flat table as an example. Okay, this is my data look like. And if we look at our table, raw table here, it has basically these 4 or 5 columns: product name, component name, and quantity. So that's what the basic the data look like. And the question is to find out if there are duplicate recipes. Now, the definition here, what make this problem really interesting. The duplicate here doesn't mean like product A contain 5 products XYZ and find out another product which contain XYZ. That's the first check. You want to make sure product has components, and what are the other product which has the same matching components. On top of that, also wanted to match that the quantity of the same component is the same. So it's like having two different pizzas, and they have everything same, but some has less spices, another has more spices, or different ingredients. Even the ingredients are the same, but the quantity could be different, right? So this one is checking two things. Okay, product with the same components with the same quantity, and then find out what the duplicate products are, or give a list of the duplicate products. So interesting problem, pretty simple, otherwise pretty common as well. The first and foremost things, experts tell you have to have a good data model. Power BI is all about data modeling and all this stuff, and that's why it is very very important to pay attention to the data model before you start even solving the problem. So what I did is it was a flat table given as a called table. I created another table called products, which is a list of the unique product numbers or products, and made it as in a dimension. And then I set it as in a relationship between component table and the products of 1 to many. So that's the first thing. So that's we have to always look into data model, because that's a key component of Power BI solutions, and to make sure our data model is to the level to give us the solution what we are looking for. Now, what next? Okay, so we create that product. Now the question is, how are we gonna solve this? How are we gonna make sure? It means if we theoretically, if we have to manually look into that, what we're gonna supposed to do is look at this product like 448305 and look at its component and the quantity and see which one is the another product with the same component and the same quantity, and then iterate over each and every component of that product and match it with the other product. And if all of those matches, and then that means that is the duplicate. To achieve this, I already have a solution in place. Of course, I tested it and worked on it, but I'm gonna walk through step by step what we're doing here, and I'm gonna rewrite a solution here. So let's first bring a product from our product table here on a grid, and build it step by step here. First thing we need to know is what are the different component for this product, right? And what is their quantity? That's the first thing what we need is. So I'm gonna start adding a column here again. Just make sure I'm adding a column here, not measure, because we can store this data in our product table to see what are the duplicate the products are compared to this product. So let's call it duplicate products. So to get all the component for this, we can take advantage of a related table function here. Related table is always, if you're looking from the one side table to the many side table, it gives us a record of all the many side table. Because of the relationship, we know product table has a relationship with the other this recipe table. So based on, like, in the context of the row, we can get all the product, all the components which are in the in our related table, right? So let's first store this in a table. Let's get a related, call it related component. So that will be pretty simple related table, and that's a table because that is a relation. What this will give us, like if we're looking at the 448305, it will give us all these values, component number and quantity. So it will give us everything. Now we don't need all the columns, right? First of all, we need to, because we are comparing the component number and the quantity together, we need to concatenate these together to make it as a unique column so that we can compare it with the other one. Rather than comparing each column, we can put these together as in a concatenated in one column and then compare against the other products. So how we can do that? We can take advantage of add columns. Again, a related table return us a component table for each product. Again, when I say each product, I'm saying in the context of the product we are looking at. So sorry, I'm just add columns. So we add columns in our related table. What we want to do here is we want to give it a name. So let's call it unique. Basically, what does that means is we are looking for component number and quantity. We can concatenate those together. We can also add this column in the table itself as well if we wanted to as a calculated column, but if there is no use of that table anywhere, there's no point doing that because it is only relevant in this particular calculation. So that's why we added the column here. So now we have a table, all the column from the table, on top of that another table which is a concatenated of component and a quantity. Now once so we have this table, this is what we are interested in, and now the next thing we need to see is which product we want to compare, right? We don't want to compare with the don't want to compare 448305 and compare it with itself and say, oh, you know what, duplicate. That's not a duplicate. So we want to exclude the current product we are at. So let's store the current product number in a variable as well. So we can call it product number from our product table because that's what we are showing here in the table visual. So now we know what our current product is. So what we need to do is we need a list of all the products excluding the current product, right? So that's what we wanted. So what we can do is we can filter all, sorry, let's go table accept current product number, right? So what we want is we want to filter our product table, and we don't want the current product. So what we can say here is a product number is not equal to current product number. Let's think through this for a second. So if I'm at the 611, so that is my current product number. So what I'm saying is, give me everything from the product table. So remove any filter on it. And again, depending on what you want, if you want to, in this case, it will always be all. So give me all the products. And then I'm saying is, okay, filter on the product number. So basically this particular variable will contain all the rows from the product table, except if we are at the 61611, it will not have that particular row. If we have a 611 612, it will not have that row, but rest of the rows. So we got everything here. So now we know, okay, what our current product components are, what our current product is, what are the other products in our table. Like, so that's so we get this far. So now what we need to do is we need to find the matching products, right? So each table we need to find the matching, each product we have to find the matching product. So let's create another table called matching products. So think about that. What would be our method to do that? What I wanted to do is take the component of each product, right? Take the component of each product, add the unique value to that, and then compare it with the currently selected unique values, or the unique value of component of current product. Actually, we should call it uh, this variable. We can have more specific current product related component, right? So what are the matching products? So the first thing what we need to do is we need to generate. So what we can do here is, let's start with the generate. Again, I'm not going to explain about the generate function. I already have a video on these generate series and generate all functions. So what we want is on the generate, on the table one side, what we want is, even if you look at the description of this, what we want on table 1 and table 2, the second table expression will be evaluated for each row in the first table, right? Returning the cross join. So what is our first table? Our first table, we know what are, we want to get the component of all other products. So that's our first table, because we want to see all the components of the products we have in which we are interested in to compare against. So for each product, it means we need to get the unique component and quantity, the way we did it for the current one, and then we see which one of those does match with our current product related components. If they match, all of those matches, it means that's a duplicate. If some of those matches, it means it is not a duplicate. So what we're going to do here is we're going to use intersect. Let me explain what intersect is going to do. It says return the rows of left side table which appear in the right side table. Okay, one thing we need to do here is, before we proceed, from this particular one, the current product related component. So this is returning the whole table, and then we adding the unique column on top of that. We don't need all the columns. We are only interested in the unique column, which is made up of component and quantity. So I just want to do that right now. What we're going to do is select columns. Select columns. Select again columns. from this table, and which has, and then we can, which column we want to select. We just want to select the unique, because you have to first give the name and then the column which is unique. So basically what we're saying is, I took all the component from my related table, component table, concatenated component number with the quantity, and from that created a table with all the columns plus the unique column we created. But I'm only interested in the unique column because I just want to compare that one. So coming back here, left hand side table is always, because our baseline is this table, that is current product related component, and then we're going to see which other ones are matching with it, and we are iterating over each product in our product table. So again, we need to do it the same thing here. What we need to do here is, we first need to get the related table, again sorry, related table. So now I just want to make sure you understand this. The related table in this particular context is in the generate, which we have the first table, which is based on, is giving us all the product except the current product. So it will iterate over each and every product and give us the component of the each product, right? So let's say if we have 1, 2, 3 products, and if we are the second product, this related table will first give us the component of the first table, then give the component of the third product, first product. Second we are excluding because of this filter, and then it will give us the component of the third product. So it's iterating over all the stuff. So what we're going to do is, again, the same thing. Basically this whole command here, we can get that and copy it here. Okay, so this will, now let's see what happens here. Where we are, so intersect, and here you go. So what does this means is, if one product has a component ABC, and other component has other product has a component XYZ, this intersect will return no row, right? Because what we're saying is always ABC is our baseline, and then we're saying, okay, intersect give us whatever is in the right table, give us the rows in the left table, and we know left table is our the baseline, that's what we want to compare. So that's what this will return, either some rows matching, whatever the matching rows are for each unique value, it will give us that. Now this, until this point, what we have here is, we know our baseline unique component R, and then we are iterating over all the component of the other products in our product table and finding which are the matching. Now this table will give us a table of the matching rackets wherever it matches, but that doesn't work, that doesn't solve our problem, because we want to make sure that the product we are looking at, if this has the 3 components with some quantity, the other product also have the same 3 products. We don't want any other different products. We want that it has to have the same 3 products, 3 components with the same quantity. And if, let's say, we have a A10 component, B A10 component with the $10 quantity, A20 component with the 20 quantity, A30 component with the 30 quantity, but the other product had a A10 and A20, but doesn't have the A30. So what this intersect is going to return is, it's going to return A10 and A20, and then we will have a product with those 2 components, but that's not the exact match. So we need to another iteration on top of this. What we need to do is match all products, right? Which product has a match? Let's call it match. Let's let's call it products with current let's call it products matching with current product. So you just want to make sure naming, I'm putting it so that it's easy to read. So first what we need to do is from this table group, count the number of rows which did match with our baseline current product. So what we're going to do is we're going to take advantage of group by function. I'm not going to explain this function because already this video is getting too long. There's a lot of videos on group by, but what we're going to do is we're going to group it our matching product table on our product number, because that's our baseline, and then we're going to count the number of rows, and let's call count components, and we're going to use the function countx. I will explain what we're doing. Current group, and what we're counting here is a unique. Let me explain what it is happening. So here we got a table products where the component of those product matched with our baseline product components, right? So some might have all matches, some might have a one match, some might have a two matches and all the stuff. So we are getting all kind of rows in here. And what we're doing here is we're saying, okay, which matching products we have, the product number, group it by the product number, and see how many components actually matched with the baseline component, right? So that's what we get it here. And on top of this, we're going to add a column. What that column is going to look again in group by return us a table. We're going to say, okay, how many, let's call it is matched all components, is matched all components. So what if we are adding a column, so then we are taking this count components equal to our baseline component compared to our baseline components, which is count rows. I could have stored this in a variable as well, but I haven't. But let's put it in here. Again, to explain here, so there might be some partial matches, right? There could be product A has a 3 components with certain quantity. Product B also has a 3 component. Maybe out of those 3, 2 matched. Even the quantity did match because we are making a unique with the component plus as a quantity. So there might be partial match. There might be full match. So because we got from this table, we got whatever match, right? Even if a product A has 3 components and product B has a 1 component, this will give us a product B with 1 matched component, but that doesn't mean it's an exact same match with our baseline. That doesn't mean it's a duplicate, right? But this one here, we are checking that from this table, how many products we are counting, how many component of each product are, and then we are comparing it with our baseline component. So now we got some table here which we can work on. So from here it is pretty easy. I know we are already talking too much in here. So what we're going to say is concatenate X to find out which product matches. So we're going to say concatenate X, and we're going to filter our match product matching with current product, where is matched all components. We are only interested in the true one. So what I'm doing is concatenate X, filter our product matching with current product, where is match all components, it means true. And then what we're going to do is we're going to say product number. So concatenate those products which matched, and that's our final result. So how does that look like? So what we got is, let's look at the 1 and 2 because I put the sample data. So one product has 2 components, 11 and 12 with the 20 quantity. Product 2 has 11 with the same quantity, but it has a different component, 13, 20. So this is not the exact match. That's why it's not working. So let's look at 47061. Let's select these two rows here. So 470610 has these 5 components with this quantity. And if we look at the 575614, they have the same quantity here as well. So it means these are the duplicate, rest none is exact duplicate. So if we look into this particular table here on our product table, so it's telling us 470610 has a duplicate which is 575614. If we're looking at the 575614, it is saying 470610 is a duplicate. That's awesome. Even if there is a multiple product match, it will show up as in a comma separated. What I'm going to do is I'm going to pause this video, put some more component or product with some duplicate and see if we get the concatenated result. Let me pause this video and get back to this. Here you go. I added another product 9999 and which I made a duplicate of 470610, same quantity. So as you can see, it is separating those two products with 575610 and then 57560 is saying these two matches, of course, because they are duplicate, and 999 is saying those other two are the duplicate ones. So this is working amazingly. Interesting solution. I love it. But I found there is one small bug in this. So if you look at 1 and 2, so 1 say the 2 matched with me, that's a duplicate product, but the 2 said 1 is not my duplicate product. Whereas because it has to be vice versa, because if we're doing an exact match, they have to have match with each other. So 1 should show 2 and 2 should show 1. And if you look at the raw data, 1 has 2 component, 1 to 11 and 12. 2 has 3 component, 11, 12 and 13. It showed up, 1 showed up match because it matched to 11 and 12. It was not interested in the component 13. And whereas the 2 says, okay, I have 3 components, only 2 match, and then because of the count in our duplicate product column, because of for the 2 this did not work out as a false, and that's why it's not working. So we need to further tweak into this, but anyhow, I'm not going to do that. I'm going to leave it here for you guys to figure that out, how to do it. In few weeks I will have a kind of a solution how to solve that last piece of this particular DAX solution or the challenge. I hope you learned few things out of this video. We use a lot of functions here. Related table, very simple. Generate, add columns, intersect. There's like a 3-4 different DAX functions has been used to solve this a very simple but super complex problem. Let me know what do you guys think about that. Again, make sure to join my channel, subscribe it, hit the bell icon so that you get notified when the new video comes out. Until next video, have a great day. I'm bringing more videos, so stay tuned. Thank you very much. Bye for now.